In this video, I'll be demonstrating the concepts of upcasting and downcasting. But before I actually go ahead and do that, I just want to give a quick recap on what we did in the last video because it's kind of important to give that intro before I jump into upcasting. It shouldn't take long. What I've got in my package is 4 classes. Let's start with the base class. This is the animal class, and I've given a detailed explanation of what abstract classes are and how we built these classes from scratch. So what we have is an abstract class called animal, and this abstract means it's incomplete because it's also got an abstract method that needs to be implemented by the child classes. So what we have here is a constructor, a getter method, an abstract method that needs to be implemented by child classes, and a method that is concrete, meaning it's actually a complete method. We also have 2 child classes, the cat, which extends the animal. It's got a constructor. It's overriding and implementing the abstract method make sound, which now makes this class a concrete class. And it's also got a method with specific behavior of the cat called climb tree. Now, the dog also extends the animal class. It also overrides the abstract method make sound, which makes this class a complete class or a concrete class. It has also got a method with specific behavior called fetch ball. Then in our tester file, what we have is an object of cat, and using that reference cat, now let's call this cat1 because we have a second cat there. We want to create a third and possibly a fourth object. Okay, so we have an object, a reference of cat1, and from that reference we called make sound. This is the abstract method. This method is coming from the animal class, the eat, and the climb tree is coming from the cat class. This is specific to the cat. So only the object of cat can actually call this method. Same thing for the dog. It's calling the abstract method make sound, and it's calling the eat method that's sitting in the animal class. And it's calling the fetch ball, which is only sitting in this class, the dog class. We also mentioned in the previous video that you can't really create an object of the animal class because the animal class is an abstract class and it means it's incomplete. So we can't really say new animal. This is not allowed. I'm going to comment it because we're getting compiler error, but I had it there as an example to show that this is not possible. However, we can use the animal class as a reference of type. What that means is I can use it as a type. Yeah. Saying that this reference cat2 is of type animal of the base class. Here it was using the child class. Here it's using the base class. But what's important is when you create an object, it has to be an object of the concrete class, like cat or dog. But you can use it as a reference of type. But what that also means is that every time I use the reference cat2, or any reference that's coming from the animal type, it can only call methods that sit in that class. So we can only call eat, we can call make sound because this, although abstract, it has been implemented by the child classes. So we can't really say cat2 dot climb. It's not, I don't have access to this because the reference type is of animal of the base. It doesn't know anything about the child classes specific behavior methods. And the same thing for the dog. I can't say dog2 fetch ball. It's not visible. Okay, so what's the difference between doing something like this and something like that? Now here, I've got a comment. Using a superclass type like animal allows for more general access. So you can access all the methods that are in the base class. While using the specific subclass like cat or dog provides access to methods specific to that subclass. Now, which one do you choose? It really depends on the level of abstraction and functionality that you need in your code. Now, this brings us to our next point, which is the point of the video, which is what is upcasting. So let's see what we have here. Upcasting involves casting a reference of a subclass type to a superclass type. So for example, I have a reference here called cat1. This is of type subclass. So I'm going to use, sorry, I don't want to cut, I just want to copy. I'm going to use that here as an example reference pointing to cat or dog objects. So here I'll say animal, let's call it cat3, is equal to cat1. Now this is basically casting a reference of a subclass, this subclass type to a superclass type. That's the cast. Now here you notice that this cast is implicit and it doesn't require an explicit cast. Why we don't need to do an explicit cast? Because this type of casting, upcasting from child, so here I've got it in here, from child to parent, is safe. There is no issues, so we don't need to explicitly do a cast. It's safe because all child objects are also instances of the parent class. So there's nothing that can go wrong in here. Only that cat1, cat3 can only call methods that sit in the parent class in the same way we've shown here. So this is also an example of upcasting. No explicit cast has been made. We have a superclass type pointing to a subclass type. So here there's been an upcast as well, but let's keep going. So here we can call the eat method. And I'll run it. So these Whiskers meow, Whiskers is eating, is all coming from the first reference, cat1. This part here is coming from dog1. This is from cat2. The cat is eating, test2 is eating, test2 meows. And here, test3, the dog, I'm sorry about the names, but anyway, this is coming from dog2 reference. And this is coming from cat3. And because cat3 points to the same object as cat1, so we get Whiskers is eating. So that's an example. And let's do the dog. Let's do something here for the dog. Animal dog3 is equal to dog1. Dog1 was called, it's called Buddy, right? So eats. We can also call cat3 dot make sound and dog3 dot make sound. But same thing, we can't do fetch. We can't do dog3 dot fetch. It's not even there. And that's again for the same reason we said before, because the base class here is only going to give us general access, which is only methods that are sitting in the parent class. Okay, let's give this a run. So because we know cat3 is pointing to cat1, so it's eating and it meows. And dog3 is pointing to dog1, so Buddy is eating and Buddy barks here. Okay, so that's what we have for upcasting. Let's look at downcasting. Now, downcasting involves casting a reference of a superclass type to a subclass type. So it's kind of the other way around. So let me show you an example. So let's say I've created an object called cat4, a reference, and I want to give this, I want this to point to cat3, but cat3 is of a superclass, is a reference of a superclass. So here I need to actually do an explicit cast. I don't know what I've written that requires an explicit cast. Okay, so what that means, I need to explicitly say or convert this to a cat object. And only now I can do cat4. Now I have access to all the features that are of the cat class because we did a downcast. What downcast mean again? This is a reference of superclass because cat3 is a reference of superclass. And we have casted that reference to a subclass type, which is cat. Cat is a subclass. So this is what we mean by from parent to child. So I hope this made sense. What else do we have here? When do we use this? It is used when you have an object of this superclass type, like cat3, but you want to access methods or fields specific to the class, the child class. Here, we require an explicit cast, but this can lead to a class cast exception if the object being cast is not an instance of the target type. For example, if I said dog3, for example, let me actually run it first with cat 3, just to show you. Now, Whiskers is climbing a tree because cat 3 is pointing to cat 1, and cat 1 is called Whiskers. And because I did a downcast here from parent to child, I can now access the features or the methods that are sitting in the cat class, like climb tree. Okay. We can do the same also for dog. Dog 3, sorry, dog 4 is equal to, I can't do this because now I need an explicit cast. And since dog 3 is of type superclass, I need to now do an explicit cast. I need to explicitly let Java know that I need this to be converted into a child type. And then from here, I can say dog4.fetch. Now I have access to the dog class specific methods. Let's give this a run. And like we said, Buddy is fetching the ball. Why is it called Buddy? Because dog 3 points to dog 1. Dog 1 is called Buddy. And now we have access also to fetch the ball. Now, what I wanted to talk about is the class. If the object being cast is not an instance of the target type, it's going to throw a class cast exception. What that means is, let's just say that I try to do a cast for a dog object into a cat. Now, I don't even have any compiler errors. It looks fine. But if I run it, there's going to be a problem here when we reach that point. It says at line 78, that you cannot cast to a class, a cat class, due to the class cast exception. It's not compatible. So you want to really be careful when you do downcasting. You only want to do that because you have to explicitly do a cast, or you only want to do that when you really know that this is really compatible, if that makes sense. So it's like you try to cast an integer to a string, it's not going to work. So that's pretty much it. This sums up our video for upcasting, which is casting from child to parent, and downcasting parent to child. I hope this was helpful, and I'll see you in future ones. Thank you.